Here are the answers for the section 13-6 homework. Question number 1, we're asked to find this sum. Let's substitute a couple of the numbers for j to see what the series starts to look like. Starting with j equals 1. 1 minus 1 is 0, 2 to the 0 is 1, and 5 times 1 is 5. So the first term is 5, and notice that there is a 5 in that position. Now let's put in 2. 2 minus 1 is 1, 2 to the first is 2, and 5 times 2 is 10. Now the third number, let's put in a 3 for j. 3 minus 1 is 2, 2 to the second is 4, 5 times 4 is 20. And that's as much of the expansion as I'm going to show. Notice that the first term is 5, that's the value of a in our formulas, and from term to term there is a consistent ratio. Looks like you're timesing by 2. And notice that there was a 2 in this position in the formula. So we have a geometric series, and we want to find the sum of 7 terms. We could keep doing the expansion and then add it up, or use a formula. I'm going to use the formula. S sub n equals a minus a times r to the n divided by 1 minus r. That's on page 512 of our textbook. We want to find the sum of 7 terms. So in place of a, fill in 5. In place of a, put in 5. For r, fill in 2. For n, fill in 7. And then in the denominator, 1 minus 2. Then evaluate that on a calculator. And the answer is 635. When I typed it in, I typed 5 minus 5 times 2 to the 7th and then pressed enter to figure out what the numerator was, and then divided by -1. Now for number 3, I noticed that the series that we're finding the sum of has the same general formula look as the previous one. So this time I'm not going to take the time to do an expansion and instead just use the formula. Because based upon what we learned last time, the number in this position is a, and the number in this position is r. So we want to find the sum of 6 terms. A is 12, and then 12 times, now r, and then the n power would be a 6. And that's divided by 1 minus the 1/2. Take a calculator to evaluate that. The result is 189 all over 8. Next, number 5. Again, I'm not going to take the time to make an expansion, and I'll just use the formula. We want the sum of 6 terms. It's equal to a, which is 3, because that number right there is the a, minus, and then a again, times r, which is -1/3, because that number in that spot is the r, and then the exponent is n, which in our problem is 6, and then down here, 1 minus the value of r. And then take a calculator to evaluate that. And the answer is 182 all over 81. Next, number 7. This will be the value of a, and this one here will be the value of r. We want to find the sum of 6 terms because that number is a 6. So a is -2/5 minus, and then a again, times r, which is 1/2. The exponent is n, which is 6. And there's a denominator, 1 minus the value of r. And then evaluate that on a calculator. The result is -63 all over 80. Next, number 9. Says find the sum from this progression. We're given the first term, the last term, and the common ratio. So because there's a common ratio, it's geometric. The general formula is S sub n equals a minus a times r to the n all over 1 minus r. To use this formula, we need to know what n is. We need to know the number of terms. And that information is not given to us. So along with the formula for sum, let's also use the general term formula for a geometric. That formula was a sub n equals a times r to the n minus 1. For a sub n, let's use our last term and fill in 324. For the letter A, that's 4. For R, it's 3. And n is the thing we don't know. Now let's solve this for n. First, we could divide both sides by 4. That makes 81 is equal to 3 to the n minus 1 power. The variable n is in the exponent, so we could get this answer using a logarithm or using observation or guess and check. For instance, I know that 3 to the 4th power makes 81, so the exponent on the 3 has to be a 4, therefore the n has to be a 5. Now that we know the answer for n, we can go back and use our sum formula. The sum of 5 terms is equal to 4 minus 4 times 3 raised to the 5th power divided by 1 minus 3. And evaluate that on a calculator. The answer is 484. Number 11 you can skip because it has trigonometry in it, and we didn't study that. Next, number 13. We want to find the sum using this information. Again, the formula for a geometric series is S sub n equals a minus a times r to the n divided by 1 minus r. We do know what a is, we do know what r is, but we don't know what n is. So we need to find n. Let's use the general formula as well. A sub n equals a times r to the n minus 1. For a sub n, let's use our last term, which is 1/4. For a, put in 64. For r, put in negative 1/4. And then the n is the unknown. We can divide both sides by 64. So this is 1 over 256 is equal to negative 1/4 raised to the n minus 1 power. Let's solve for n like we did in the last question. Negative 1/4 raised to the 4th power would make 1 over 256. So for this exponent on the negative 1/4 to be the 4th power, then n has to equal a 5. Now that we know the answer for n, we can go back and use our sum formula. The sum of the 5 terms in the series is equal to 64 minus 64 times negative 1/4 to the 5th power. And the denominator is 1 minus negative 1/4. And then evaluate that on a calculator. The result is 51 1/4. Next, number 15. Find the sum of this geometric progression if you're going to sum up 7 terms. So we have the sum of 7 terms is equal to the value of a minus the value of a again times r, which is 1/10, to the 7th power, divided by 1 minus 1/10. The reason r is 1/10 is because that's what you times by to get from this term to the next term. Now type that in your calculator. The result is 1111.1 repeating, or that would be the fraction 1/9. Next, number 17. We're given some values about a geometric sequence, and we're asked to find a and L. One of the things we're given is the sum of n terms, and we have a formula for that. S sub n equals a minus a times r to the n divided by 1 minus r. In place of S sub n, fill in 1022. We don't know what the a is. In place of r, fill in 2. In place of n, fill in 9. That's all divided by 1 minus 2. Now let's start to work on this equation. The numerator will factor because there's an a in both terms. We can factor out an a, leaving 1 minus 2 to the 9th power. And the denominator is negative 1. Now we can multiply both sides by negative 1. Then to get a alone, divide by that term right there. That makes a equals 2. And that was one of the things we were asked to figure out. So we now know A is 2. The other thing we need to know is the letter L, the last term of the sequence. Let's use our general term formula. A sub n equals the first term times the value of r, n minus 1 times. We're given that n equals 9, so we can find the ninth term, which is the last term in the sequence, if there are 9 terms. For A, substitute 2. We had just figured out the A. For r, it's 2, and then 9 minus 1 is the exponent. Take a calculator and figure out what this makes. It's 512. So the last term is 512. Number 19 is very similar. We're given some information. We're asked to figure out what R is and what L is. One of the pieces of information we're given is S sub n, so let's use that formula. A minus A times R to the n divided by 1 minus R. For S sub n, fill in negative 1,302. For A, we know it's negative 2. We don't know what R is. And for n, we do know it's 3. And that's divided by 1 minus r. Let's simplify the right-hand side. This is negative 2 plus 2r cubed over 1 minus r. And that factors. We can factor out a negative 2, leaving 1 minus r cubed over 1 minus r. 1 minus r cubed is a difference of cubes, which we studied in our chapter about factoring. So let's factor that difference of cubes. Let's go up here and do that. We have negative 1,302 is equal to negative 2 times, and now we're going to factor the difference of cubes. It makes 1 minus r times 1 plus r squared. And that's all divided by 1 minus r. Next step, the 1 minus r's cancel away. So now we have negative 1,302 is equal to negative 2 times the r squared plus r plus 1. Let's divide both sides by negative 2. And that makes 651 is equal to r squared plus r plus 1. This is a quadratic equation, so let's make standard form where we get it to equal 0. We have r squared plus r minus 650 equals to 0. And then let's solve this by factoring. R times r, positive times negative, and 26 times 25, which makes 650. In the first parentheses, r is negative 26. And in the other parentheses, r is positive 25. So there's actually 2 different possibilities for r. So over here where we were going to write our answer, it could be negative 26 or positive 26. Now we need to find the value of L, the last term. But because we're told n is 3, we know that the last term is really referring to the third term, a sub 3. If we know the first term and we want to get the third term, we can take that first one and times by the value of r twice. So if r is negative 26, this would be the work that gets us a sub 3. But if r is 25, then this work would get us the value of a sub 3. So let's type both of these in because there's going to be 2 different possibilities for the last term. The first one is negative 1,352, and the other possibility is negative 1,250. Either of those could be values of L. Next, number 21. This time we want to find L and find N. Let's use our sum formula again. So negative 25 is equal to 5 minus 5 times r to the n power divided by 1 minus the r. Now let's solve this for n. So first we could multiply by 3 on both sides, getting negative 75 equals 5 minus 5 times negative 2 to the n power. Next, subtract 5 from both sides, and we have negative 80 is equal to negative 5 times negative 2 to the n. Now divide by negative 5. We have 16 is equal to negative 2 to the n. Well, negative 2 raised to the 4th power would make 16, so n equals 4. And over here we can write 4 on that answer blank line. Now let's get the last term. The general formula for a geometric is a sub n equals a times r to the n minus 1. And now that we know that n is 4, we know that the last term is referring to the 4th term. We want to find a sub 4. Now evaluate this answer. Negative 2 raised to the 3rd power is negative 8, and 5 times negative 8 is negative 40. Next, number 23. We're given some information about a series. We're asked to find r, and we're asked to find n. I'm not sure how to use the formulas here, because our formula for sum uses the n and the r. So if they're both unknown, we can't really solve for one of those variables. And our general term formula also has an n and an r in it. So it's unclear how we would use the general term formula either. Let's write out the series to see if we can see any patterns. The first number is 30, and then you add, and then there are some unknown terms, and we're told the last one is 0.003. Now we know it's a geometric series because we're looking for an r, a common ratio. So what might be the pattern from term to term? To help us discover that, look at what the sum looks like. It's 33.333. Think about how you would get such an answer. That could come from 30 plus 3 plus 0.3 plus 0.03 plus 0.003. If you added those numbers together, that would build the number 33.333. So we didn't know what r and n was, but we are able to actually figure out the entire series that's in number 23. And with that information, we can certainly find r and n. There are 1, 2, 3, 4, 5 terms, so n is 5. And what's happening from term to term? It looks like we times by 1/10. So r is 1/10. Now the review assignment. Page 510. We're looking for the positive geometric mean in between these numbers. So we can use the formula, the square root of 1/2 times 8. That's the square root of 4, which makes 2. This answer is 2. Now page 499. This time we want to find 3 arithmetic means in between these numbers. So let's use the general term formula for an arithmetic. For a sub n, use negative 10. For a, use 18. There are 1, 2, 3, 4, 5 terms showing, so put 5 for n. Subtract 18 from both sides, and then divide by 4. D is negative 7. That means we subtract 7 each time. So 18 subtract 7 is 11. 11 subtract 7 is 4. 4 subtract 7 is negative 3. Negative 3 subtract 7 brings us to the last term.